All right, what did Q stand for again? The who? Okay, heat lost or heat gained, either one. M is, CP was, and delta T. It doesn't necessarily have to be lost, just change, okay? It could be gained, could be lost with a change in temperature. All right, so since the question said calculate heat, which one are we solving for? Q. All right, so what's our mass they gave us? 15.2 grams. All right, what are we going to do with these other two numbers they gave us? What are those? Temperatures, and what do we do with them? Subtract them. So what did you get when you subtracted? 38.7? All right. So what do we do to get CP? Because there's no other numbers in the question. You look at it on the blue chart. So what element did I give you in the question? Gave you copper. So what's copper's specific heat? 0.385. All right. So all you have to do there is multiply. And what do you get? 226. And what unit goes on it? Q is a J. Joules. Any questions about number one? Yes? No? Okay. Number two. All right. What is the volume of gold with a mass of 45.7 grams? All right. What are we going to do to find volume if I give you a mass?
Right. The equation for density.
Going to use the density formula. So, density equals mass over volume. I asked you to find volume. I gave you the what? 45.7. So I need the what? Where do you find it? The reference table. So what's the reference table tell you the density of gold is? 19.31. All right. So to solve, we're going to do what? I'm going to cross multiply and get 19.31V equals 45.7. To solve, I'm going to divide by 19.31 on this side. That'll give me V. So I got to divide by 19.31 on that side. What's 45.7 divided by 19.31? 2 point what? 37. What unit am I going to be left with? Centimeters cubed. All right. For those of you who might not have known that, your density said grams per centimeter cubed on the reference table. And I gave you grams in the word problem. So what's going to happen to the units? Grams are going to cancel out and be left with centimeters cubed. Remember that? Okay. Now, for the last question, I gave you an ion. How do you know it's an ion? It's got +5 on it, right? So, how do we find protons tomorrow or Wednesday on the benchmark? The atomic number. Okay. So protons are always the atomic number. Now, it doesn't necessarily have to be the bottom number on the benchmark. How do you know it will be that bottom number? What gives it away? It's smaller. Okay. The atomic number is always the small number. So that's how we know it's the 33. Okay. Because I could have the 76 and the 33 flipped. Okay. So it's always the smaller number. So to do the electrons, how do we do the electrons? Okay. It's always the protons. So we know it's the 33. And if it wasn't an ion, we'd just stop there. But what's this +5 mean? All right. That means we lost 5 electrons. So we're going to subtract 5. So 33 minus 5 gives us what? 28. Okay? And then we're down to neutrons. And what do we do to do the neutrons? Mass minus number. So mass minus number will be 76 minus 33. What's that? 43? Questions about how to do any of the three things that I selected from days of old? No? Okay. Anything from last week that you need to ask about before we test tomorrow? Now, I uploaded the 14 questions that were around the room for anybody who didn't write them down. They're uploaded on, I'm pretty sure I did it on Friday. I may have also done it for today. I'm not sure if I did today's homework assignment or not. But I did do it for Friday. So Friday, if you go to the website for homework, all 14 questions are uploaded. The answer key that I did all worked out correctly are uploaded, because I know there's 3 or 4 of you who did not finish all 14 questions. So all 14 questions are uploaded and all the answers are worked. So those of you who did not finish it, those are there for you also. Okay. So those are on the website. If you're Devontae and you're giving me openings, that is fabulous. Put them on my either laptop is fine. And I'll take care of those later today. So remember what I said. What I say Tuesday. If I get them by Tuesday, I will not mark them late. Makeup work. I've got to have it by Thursday. Ms. Curry said Wednesday. I'm being ultra generous and saying Thursday because I have to have it graded in the computer by Friday because Power School is down this weekend. I cannot enter any grades this weekend. It's undergoing maintenance, okay? So I have literally Thursday night to grade everything and turn it around by Friday morning. So if you have anything missing, and there are a few of you in here who have missing work, I have to have it by Thursday, okay? All right. We're moving on to a new subject. So for those of you who take notes, I'd start a new page in my notebook. Let's see. Get rid of this. No, I don't want to update. Now, the next topic we're going to do, really the next 3 topics we're going to do, has one formula that's math that we'll do today. We should get to it by the time we switch for second period. And other than today, and we take a quiz on it, which will be best guess Thursday or Friday of this week. We won't do math again for about 4 weeks, other than adding some numbers together. Like when we count electrons. We won't do any math. So for those of you who have been, oh my God, this math is killing me this fall. I feel like I'm in another math class. I need something else. Well, we're about to do that. Most chemistry teachers in the state start with what we're going to do for the next 4 weeks. However, I don't think it's the most fascinating of topics to start with, and I think it tends to burn people out on chemistry pretty quick. So I don't start the semester there. I tend to flip-flop the topics and do what I did first and do this last. The next couple days are a tough slog for a lot of people because it is so different. People are like, are you kidding me? I'll let you be the judge. But hopefully today and Thursday we can get through most of it. Friday's topic I really like, Friday and Monday. Because that's the jumping off point for all of the next 4 weeks. It's the ground laying part. This part they put back in the curriculum about 5-6 years ago, and I have no idea why. I left it out, but they stuck it in, and you might see it on the exam, so I've got to do it. The worst part about the exam is it's only 45 questions. 45 questions will not cover the entire semester. So do I know what's on the exam? Nope, I never get to give the exam. I have absolutely no idea which parts of the content you'll see. So I'm just shooting in the dark, okay? So, what is the wave particle nature of light? It's a theory, okay? Once upon a time, it sounds a little bit like a fairy tale. Scientists believed that electrons behaved as particles. Okay? meaning
good morning. We will be having our Honor Society induction ceremonies beginning in a few minutes. Students, please be mindful of appropriate behavior. We have had assemblies that require a lot of crowd participation. This is not one. We are here to recognize upperclassmen who have worked hard, and they are now being recognized for it by being inducted into one of our 4 honor societies here at the high school. At this time, we need all freshman classes with their teachers to please report to the auditorium. All freshmen will be seated in the balcony.
all right. We'll just go a little further because if they go
All planning period teachers, please make your way to the front lobby, to the auditorium, to help students enter into the auditorium in an appropriate manner. Thank you.
I'm sure we'll be called shortly. Remember, y'all are sitting with me. Try not to get separated the way we did last time. Be pushy so that you stay with the group. All right? Now, scientists believe that electrons behaved as particles. And I put as matter there, so I want you to think about it. Think about a BB or a marble. You guys know what that looks like. You can relate to that. That's sort of the way they believed electrons behaved at this time. All right? Now, at the same time, they believed that light behaved as a wave. Okay? Now, hopefully you remember a little bit about waves, but if you don't, it's okay. That's all part of our discussion for after the assembly, because most of you probably don't remember a great deal about that. Waves are not matter, okay? They're energy. Now, the revolutionary part of this, oh good, he's there again. Day's getting better. Sorry. All right. The revolutionary part of this theory is that scientists discovered that electrons can behave as light. Now, think about this. How can electrons behave as light? Electrons are matter. So how can electrons behave as energy? Well, if electrons can behave as energy, can light behave as a particle? That's their theory, okay? They also believe that electrons can behave, whoops, I meant to say light there, that light can behave as a particle. Now, think about it. The light from these lights, fluorescent lights in here, can be a particle, can act like a BB or a marble. They could possibly have mass. They could hit stuff and knock it out of the position that it's in. That sounds fairly bizarre to most of us. In the early 1900s, this was really revolutionary. Okay? So, and believe it or not, scientists proved that this was correct. Okay? So, in a nutshell, scientists proved that both electrons and light can behave as both particles and light. Or let me say waves there instead of light again. It doesn't make much sense. Y'all stop getting bent on shape. I changed my mind a lot. Scratch it out. Oh, that looks messy. Okay.
Yeah, you're right. It makes no sense to
Is only going to get worse.
like.
It will make more sense. Let me say this. It will make more sense on Thursday when we talk about neon lights and the photoelectric effect, because I'm going to give you two examples where this works.
Like, do you
Okay.
think that light creates heat and then
Nope. I mean, like, light is going to shine on a piece of metal, and then an electron is going to be ejected from the metal. Okay? Because light itself, I mean, if I throw a ball at a can, the ball is matter. I can hit the can with the ball, and we can see the can fall down, right? But generally speaking, we can't shine light on a can and watch the can fall down. No. However, there is a phenomenon in science.
At this time, we need all of the upstairs
Okay.
and all of the science and all of the back
Remind me.
CTE
Talk about
area.
that when we get
Upstairs science, back CTE area.
All right, remember, we have a line leader. We have to go together. Leave all your stuff here. Bring your cell phones, clearly. Wait at the door.